So the Pythagorean theorem is a theorem that describes the relationship between the sides of a right triangle. So if you remember, we have in a right triangle, we have the right angle, and then we have the sides, and this is a leg, and this is a leg, and this is called the hypotenuse. And the legs are the two sides that meet at the right angle, and the hypotenuse is the side that's opposite from the right angle. Well, this guy Pythagoras was kind of a sort of a mystical mathematician back in Greece a long time ago. He discovered this relationship between the sides of a right triangle, and it's a very important one because we can use it to solve lots of problems. And this relationship that he found was that if you take the two legs of a right triangle, and square them, remember squaring is multiplying by itself, you get the hypotenuse squared. So the simple way to look at that would be like this. If I have, and this is one that works out quite nicely, so if I have a 3, 4, 5 right triangle, meaning that the sides of this right triangle are 3 is the shortest side, 4 is the next longest, and 5 is the longest side, and the hypotenuse is always the longest side, that this relationship will hold. And it only holds for right triangles. So you can actually use this relationship as sort of a test. So if we're going to test this triangle to see if it really is a right triangle, we put a right angle in there, so because I knew it was, but if we just erase that for a second, and if we're going to test to see if it is a right triangle, we would take the two legs, so 3 and 4, so 3 squared plus 4 squared, and say it's equal to 5 squared. And then we can check and see. So this is 9 plus 16 is 25, and we get 25 equals 25. So that checks. It is a right triangle. So we can use the Pythagorean theorem as a test of right triangledness. So let's try another one to see. So if I have a let's say this one is 4, 7, and 12. Okay, and I put a right angle there. I shouldn't do that because I haven't tested it yet. Let's see if it really is a right triangle. So I'm going to take the legs. So the legs would be the two shorter sides because the hypotenuse is always the longest side. So the two legs are going to circle in blue here. We would have 7 squared plus 4 squared equals 12 squared. So that's 49 plus 16 equals 144. And so what do we get? We get 65 equals 144. And clearly that's false. So because this right triangle relationship does not work for this triangle, because it's not equal, we know that this is not a right triangle. So this triangle failed our test. And why do we know it's not a right triangle? Because the Pythagorean theorem did not hold. Now there's two situations that come up when you're solving these problems. Sometimes when you're given a right triangle, you're given both legs. So if I give you 4 and 7 and ask you to find the third side, I know both legs. So remember, the Pythagorean relationship says if I take the legs squared plus the legs squared, I get the hypotenuse squared. And so that means if I take 4 squared plus 7 squared, I'm going to get this x squared, which I don't know yet. So that's going to be 16 plus 49 equals x squared. And so that would be 65 is x squared. And then I don't know x yet because this is 65. And what I want you to think about when you reach this point is, could you have this relationship where this was 4, this was 7, and the other side was 65? If this was 65, 65 does not seem like it goes with the numbers 4 and 7. It seems too long, and it is too long, because what we forgot to do is we want to find x, not x squared. And so remember that the opposite of squaring something is to take the square root. So if I want x, I have to take the square root of 65. And using a calculator, we can calculate that out. And the square root of 65 turns out to be about 8.06. And then some other numbers, because this is not a perfect square, so it's an irrational number. So we get a big long decimal. And usually we're round to the tenths place, so we're going to say x equals, it's about 8.1. Or sometimes we just leave it as the square root of 65. So in this case, we knew both legs, and when we know both legs, we square them and add them to find the hypotenuse squared. And then we have to remember that the second part is we're gonna take the square root. So let's try one more. So here's my triangle, and I'm going to say this is 10, this is 15, and I want to find the length of the hypotenuse. So I know that these are the two legs because they meet at the right angle. So I'm going to take 15 squared plus 10 squared. It's going to be equal to x squared. So 225 plus 100 equals x squared, and I have 325 equals x squared. And the most common mistake would be to say, okay, this is going to be 325. But look at these numbers, 10 and 15 and 325. They don't seem to go together very well. 325 seems too big, and it is, because we forgot the second step. And the second step is that we have to find x, not x squared. And remember, to undo an x squared, you have to take the square root. So we're going to do the square root of 325, and we'll use a calculator to figure that out. 325 square root. And what we find is that that's about 18.02. And again, it's an irrational root. It's a big, long root, so you get lots of decimal places. And we're just going to round to the tenth. So 18.02, this is a small number, so we're going to say that's about 18.0. And we solved the problem using the Pythagorean theorem. Okay, so the other situation that can happen is that when we have a right triangle, we might know the hypotenuse in a leg, but the other leg we won't know. And in this kind of situation, it turns out to be a subtraction problem instead of an addition problem. Remember, the Pythagorean theorem says that leg squared plus leg squared equals the hypotenuse squared. Well, when I don't know one of the legs, like this one, maybe that's this one, I don't know, the way you take care of that is you remove this leg squared to the other side. So we subtract this one, subtract it, and you end up with the leg squared is equal to the hypotenuse squared minus the other leg squared. And we know, we should just look carefully, we know that these are the two legs because they meet at the right angle. So I know one leg, I don't know the other. So that should tell me I'm going to be doing subtraction. So I'm going to say the leg I don't know, x squared, is going to be equal to the hypotenuse, which is the longest side in the right triangle, 12 squared minus 11 squared. And so that works out to be 144 minus 121, which would give me 23. So x squared is 23. So the most common mistake would be to say that this side is 23. Um, but look at the numbers, it really doesn't make sense. The longest side is the hypotenuse, which is 12. This side can't be 23. So what did we forget? We forgot to take the square root. So x is going to be the square root of 23. And we'll use a calculator to determine that. 23 square root, and we get about 4.79. Remember, this is an irrational square root because it's not a perfect square. So we get a big long decimal number. Usually we round to the tenths. So in this case, 4.79, we would say that this is going to be about 4.8. So let's try one more. So here's our right triangle. And maybe this side is 8 and this side is 3. So the first thing is to ask ourselves, what do we know? And we know the hypotenuse because this is the side opposite the right angle, and we know one of the legs. So that means we're going to be doing a subtraction problem. So I'm going to take 8 squared, and let's call this x. So x squared is going to be 8 squared minus 3 squared. The hypotenuse squared minus the leg squared. And so x squared is going to be 64 minus 9. And so that's going to be 55. And you might be tempted to write 55 here as being the length, but look at the numbers. 55, 8, and 3. It just doesn't make any sense there because this is too big. The longest side is the hypotenuse, so this 55 will not work. It's an error. What we did is we forgot to take the square root. So the opposite of squaring something is to take the square root. So the square root of 55 turns out to be 7.416, and if we round that to the tenths place, we look at the hundredths place, and it's smaller than 5, so we're going to just truncate that number at 7.4. So x, the other leg, is 7.4 units long. So let's do a quick recap. There are two situations when you're solving right triangles. So when we're solving right triangles, we may have a situation where we know both legs, in which case, if you know the legs, the Pythagorean theorem says that you're going to square the legs, add them, and you're going to get the hypotenuse squared. And then when we do that, we got to remember that at the very end, you have to take the square root. So we have 9 plus 16 is x squared, and 25 is x squared, and 25 would not make sense with the numbers 3 and 4 there. So x is going to be the square root of 25, which is 5. The other situation, I have my right triangle, and in this case I know the hypotenuse in one of the legs, and the other leg I don't know. So in this case, the Pythagorean relationships turns into a subtraction problem. So instead of leg squared plus leg squared, I'm going to do the hypotenuse squared minus the leg that I know squared is going to equal the other leg squared. And so in this case it would be 25 subtract, well let's write it out. 5 squared minus 3 squared is x squared. So we'd have 25 minus 9 is x squared, and that comes out to be 16 is x squared, x is going to be the square root of 16, and 4 is going to be x. So those are the two situations that happen when you have are using the Pythagorean theorem with right triangles.